Okay, I'm going to try OBS this time and see how it goes. I'm not sure if it's live right now. I guess I'll find out in a second. Let's see here. It says starting, but I don't know what that means. Let's see here. No? Yes? Maybe? Oh wow, that's a lot of latency. Oh boy. Let's see, is there a way of changing that setting? Low latency, it's what it says. It's a couple of seconds behind. Okay, let's see. So we got OBS here. I guess that's the window that's being broadcast. Is the quality good, guys? It's looking real terrible for me. Oh, I'm stuck in... Let's see. Whatever, I'll leave it at, that so it doesn't take forever to decode. Let's pop out chat. So this is the first time with OBS that I have, so I don't know how well this is going to go. Okay. Wow, 37 people already. Oh, it's stuck? Oh, you're stuck on 480p. Is everybody else getting 720? It should be 720. Just making sure you guys can also hear me. Is the volume good? I turn it up a little bit. Test, test, test. Hey. Yeah, I know a lot of you guys are annoyed that it's starting late, but it's really not that late. It's only 6 p.m. here, so that's good. The latency is really high, though. Wonder if there's some setting in here. I don't know. I guess we'll just deal with the delay as it is. Let's get the fire fixed up a little bit. So until today, I've always been using Simple Screen Recorder in Linux, but now I'm trying to use OBS. A lot of people suggested OBS. It seems like it's much better. Also, there's a big problem I had with the stream from yesterday where everything was all out of sync. Thankfully, somebody on Twitter is trying to get that fixed for me, but hopefully OBS will be a little bit better. And I'm going to be able to start recording at a different time than the beginning, so I don't have to wait for YouTube to edit it all. So we'll see how that goes. No, I'm not using hardware encoding. Actually, I'm curious. Oh, that is a lot of latency. 12.6 seconds. Let's see, OBS. Yeah, I'm getting a little bit more CPU usage than normal. I don't know. It's still tolerable. Latency is proportion to romantic factor of stream. That's a heck of a statement. Okay. Maybe I can change the stream settings some. Yeah, I mean, I don't know. Software X264 is the only option I got. Okay, I mean, is 12 seconds an acceptable amount of time? Well, it's 6:06, and I'm hoping to get this done in about 4 hours again today. So I guess we should get started. This one is significantly less prepared than most of mine, so I don't know how well it's going to be. But I guess we should go. Okay. You guys ready? Whoa, 137. Okay, let's go. Hello, everybody. Welcome to my first Fireside hack. And today, I have a box here from Kelvin. And for those of you who don't know, I think Kelvin has access to the best multimeter of all time. Now, they've gone through a couple changes here and there, and these might be a little different, but they're still gotta be the best, because Charles's rule of prices is the more expensive it is, the more money that's going into the pockets of those who made the product, and the less money that's going into the product that you want to use. These meters, $2.75 a piece. So, let's open it. It's full. The box is full of the best multimeters ever made. Now, you might be looking at these things and you might be thinking, wow, that looks an awful lot like the Harbor Freight Centec. And the answer is, yeah, it really does look a lot like the Harbor Freight Centec, but it's not. There's a few major differences. One is, oh good, they still have the awesome probes. Okay. Number one, the probes. The wires don't just fall out. And on this side, the wires don't just fall out, which is just amazing because, like the Harbor Freight ones, the wires just fall out, which is terrible. These, solid. Let's open it up. Let's also see if these things do the second most amazing thing. I go get the wrapping off here. Yes. Check that out. As soon as I plug it up, it just worked. That means that they included a battery. Like in a $2.75 multimeter, you got like $1 a probe a piece with these, and you got 75 cents for a battery. Throw in the multimeter for free, practically. So I've actually done a number of tests where I just basically exploded these things and tried to kill them and everything else, and they're indestructible, and they're all around just amazing. So I was curious what all could be done with them. And so a long time ago I probed them out and I wanted to find out, well, what can you do with them? And I couldn't find anything in there that really led me to really finding how I could read the data off of them. So I guess I should also show you that. Somebody mentioned, what are they? What model? They are a Kelvin 50 LE multimeter. They come from Kelvin. And they're probably made in the same factory as all the other terrible ones, but Kelvin makes sure they're extra special. So, I love them. Get them from Kelvin. That way you know they're good. So, is it still not 720p? I guess what we should do first is let's make sure that this one works, and then we will open it up. So I'm going to go plug it in to the common and that. And you know what? A lot of people say they wouldn't trust this on mains. I do. I'm going to go put this right here. I'm going to plug that one in there, and that one in there. And guess what? It's reading 119 volts. I'm comfortable with this multimeter. You should be too. Anyway, I think it would make sense to, ooh, did it just twitch out? Is everybody else having a hard time with the stream, or is it still working for you? Oh no! Let's try that again. Okay, hold on here. Sorry guys, give me a second. Ah, there we go. Let's also go. Nope, still wrong mic. Whatever. Is the sound good for you guys still? If it's still good, I'll just slide with it. Oh wait, maybe I can do that. Hello? Hello? Nope, still wrong. Settings. Audio. Hello. Okay, actually that looks a lot better. Is that better, guys? Okay. Now, I just plugged this into the wall, and I guess I should do it again, but it looks like we can't really move that around, let alone it does something stupid. So yeah, look at that. Nice 120. I don't feel any sizzling of my flesh, so that's good. So, looks like everything's fine. Yeah, by the way, it's only $2.75 if you buy 10 or more, but if you don't buy 10, you're insane. Like, there is a way of living where you have to find your multimeter, and where you will spend, over the course of a year, maybe about 10 minutes trying to find that multimeter. Over 10 years, that's 100 minutes you spend trying to find your multimeter, or making sure you have it. These things, just buy them. Buy boxes of them. Leave them around your house. Just like, leave them in the couch cushions. Whenever you need one, it'll always be within hand's reach. Amazing stuff. Oh man. Froze again? Might have to try a different camera. I don't know what's going on with this one. Let's try switching. Oh, come on. I can't switch to MJPEG. Okay, let's try that. Test. Oh, sorry about that. Definitely wrong mic. Okay, looks like we're cooking again. I will test it once more. Plugged it in right here. I'm going to turn this to 200 is the limit, and looks like it's working. Looks like the stream is still running. If the stream dies, then, well, we'll have to get a different webcam. Which, by the way, webcams also, don't buy good ones. Buy lots of terrible ones. At least that's the way I live. Anyway, that is measurement on the mains, by the way. So what I'm going to do, and in front of you guys, is I'm going to go open this up. So I'm going to have to get the camera a little bit closer here. Hopefully that doesn't freak it out. I'm going to aim it down. Let's see. Hopefully that is still within range. I'm going to go get a screwdriver here. Oh. And let's open this thing. Another great thing about the Kelvin multimeters is that it's really just two screws. Two screws and it's open. And look at this. Oh, good. Oh, wait. No, this is a different inside. This is different. Well, let's hope that this still works out. So on the inside of these multimeters here, there is actually a fuse. I believe that's for the 200 milliamp measurement. There's a big bus bar right here. It's I think it's just a current shunt for the 10 amp measurement. There is a little COB right there. It's the little, the chip is actually underneath that black dot. They have a beeper. Oh, so I forgot, the best thing about these over most of the others is that, see this feature? Oops. They have a beeper, and they're cheaper. Anyway, so back to this thing right here. So I have it's just like the normal insides. It's got a bunch of components. I'm not really sure how this is, you know, $2.75. Off-name battery. You can swap it out. It's easy to switch. I even though it offends my sensibilities, I do replace the batteries in these things instead of just throwing them away. So at any rate, yeah, I can have this powered on. Now, what I'm going to do is I'm going to just start probing around inside and seeing what some of the voltages are while the thing is in the on position. Wouldn't it be great if I had another multimeter to measure the voltages inside this multimeter? And guess what? Because I got a box of 20, I do. I love multimeters. Well, I like this multimeter. I don't really like any other multimeters. Honestly, I never really liked multimeters until I found this multimeter, but it totally opened my eyes to the fact that there could be just amazing, amazing multimeters in this world. And this is totally that multimeter. That's actually a really interesting question. I don't know if the multimeter can read itself, but sure, let's find out. Whatever, they're only $2. So I'm going to go in the back, and I'm going to switch screens so I can watch what's going on. And I'm going to probe the ground pin. Okay, that says 0 volts. And I'm going to probe the battery ground. Oh, hey, that's neat. You can. You can actually probe the multimeter with itself. That kind of makes sense. So this is the plus side of the 9 volt battery at 3 volts. This is the minus side at minus 6.9 volts. And then this right here at 0 volts is the board ground. It's a little bit odd how the chip actually works. As far as I understand, it's based off of an ISL part. Or we'll look that up in a minute. I don't think it is the ISL part, but I think it's vaguely based off of it. And then looks like that's just the power going into the chip. So, yeah, it's pretty simple. Wait a minute. Oh, there it is. Okay. Well, let's use another multimeter to probe around in, so we aren't completely crazy. So inside here, we have the ground, which is for like the whole circuit board and most of the other stuff, and then the part itself kind of generates its own, as far as I understand it, like its own funky square waves, which are used for a variety of purposes, with like the high voltage coming in there at 2.9 volts. Let's see if you see that better there, and a variety of other things. So one of the annoyances, though, is that there's no like straight up digital output on this pin here. Wait, is sound actually going out of sync? Does my mouth look like it's moving in sync? Synchronization test. Oh yeah, I gotta get my face out of the picture, otherwise it will be out of focus. Boop doop doop. So yeah, that's kind of the background of these multimeters here. Why I think they're amazing. By the way, they actually, let's just also say, they have a transistor measurement. They have all this junk over here for measuring like current, AC volts, DC volts, resistance, the diode test thing, and continuity. And they also have this funky thing right here, which I've never understood what was, but apparently it's like a square wave out. Let's go actually see what that does. So I'm going to just go hook that up to my scope here.
and I don't understand why you would ever need a square wave out. But yeah, there's totally a funky looking square wave coming out of there. That's really random. Who knows why they would want to put a square wave output on a thing like this? What frequency is that at? It's about 1 div, so that's about 10 milliseconds per whatever. Let's see. I guess that's kind of hard for you guys to see. See if I can get it to sync up. Oh, there we go. Okay, I guess you can probably see that a little bit better now. It's not a 1 kilohertz square wave. It's definitely not a 1 kilohertz. It's maybe 100 hertz, or no. It is a 50 hertz square wave. So that's a little bit weird. But I think you guys will see why it's a 50 hertz square wave soon enough. Now I'm curious, can I just probe around inside of here with just this probe while holding on to the black piece? Oh, looks like I can. Let's see here. Okay, that looks like something we can kind of work with. So right now that's 0 volts according to the board. That is the higher voltage. Let's drop that a little bit more. Right there. That's the what do you call that? That's the VCC rail for it, I think. Here, let me up this so you can see a little clearer. So VCC, ground. Ground's off the bottom of the screen. VCC. Okay, there we go. What we can actually look at though is some of the LCD elements here, and what they do is they switch the LCD at a fairly fast rate, and depending on if it's being switched in phase or out of phase with the main part of the LCD clock, which I don't remember which pin that is, it will either activate or deactivate the element of the LCD. And so by probing around here, so like I don't really know which elements are up and which ones are down because I don't have a clock I can check against, but that's fine. One of the things that I can test though is I can start probing around in some of the pins that I know what they are. Well, first of all, let me just make sure that this is the same. Ooh, hey, that's an interesting. What is that at? That's a very high frequency. That's at, wow, that's at like, what's 1 over 20? That's 20 microseconds, so that's 50 kilohertz, right? Wow. Anyway, don't know what that is. By the way, don't follow the instructions of those in chat. You do not know that. They're all trolls. So, at any rate, I think that's just synthesizing another voltage rail. So probing around, just random things here. Some of the input. Ooh, that's weird. Don't know what that is. What is that? Still functional. Whatever. We need to get to the interesting bit here, though. Let's see. One of these pins over here has to do with the integration system that they use to, ooh boy, to figure out what value to display on the screen. Don't know which pin it is though. That might be it. This is definitely different on the inside than the other one I was playing with. Yeah, it is an integrator. Let's try to switch to a normal mode. Okay, maybe it was just that 60 hertz mode that everything got all messed up at. So this looks like the resetter part. I guess that's the integrator. Okay, let's go get a power supply and poke at this. I do not know if there's a way to get those in Europe at a decent price. Oh man, I need to get some PCs. Let's put a little more than 5. Let's put about 10 volts on the multimeter leads. So it'll read somewhere in the middle. Is audio actually broken, or did you guys just me leave? No, that's completely false. Cheap and goodish quality are not, like, inversely proportional. There's a place called MPJA. Get your power supplies, if you're in America, from MPJA. They are amazing power supplies, and they're cheap. This one was from eBay. It's a pretty good power supply, and it's cheap. They put out tons of noise on the rails. They're just awful scopes. Well, okay, how do I explain? From an aspect of somebody who's trying to do a complicated analog design, like, no, these guys are not going to work. You're going to have to go spend $200 on a power supply. To somebody who wants to go plug up some LCDs, go get some circuits power, make sure that they're not drawing too much current, go spend $49.99 on a boatload of power supply for cheap. Okay, so right now, by the way, this power supply, off by 0.3 volts. Total terrible power supply. Works though. Yeah, never buy soldering irons from MPJA. Those are terrible soldering irons. But their power supplies are great. This was not from MPJA, I should clarify. I have my MPJA supply over across the room. So right now it's reading 10.5 volts. Put that over there. Let's take this. Hook up the grounds. Hopefully we'll see something interesting on one of these pins here. Okay, that looks like it's something. Looks like it's going up and down at a fairly regular rate. Actually, it looks like it's split between about 3 levels, so it's a little unusual.
This might be a little bit harder than I thought. So the period is about 1,000. 1, 2, 1, 2. So it looks like it's updating the period at about the same as the LCD. So I guess what I should point out is that what's really going on here is you have a few pins. Whoa, I have never seen that. What's going on? My Y is vibrating wildly here. Huh. So depending on the voltage, the integration system for the chip will go for longer or less long. So like if it's a very low voltage, it only goes for a short time. If it's a very large version, it goes for a very long time. And so basically the voltage is allowed to integrate over a longer period of time. Wait, no, it's still hosed. What is going on? Oh, haha. I should not be leaving this on top of the scope. Oh. Magnets. How do they work? There we go. That's a much cleaner signal. So there we go. It's not really a sine squared. Tell you what, let's pull up the data sheet that has to do with this right now. I'm going to go shrink this. Let's move this over here maybe? Yeah, that looks like that'll work. I'll move this over here. I will open up, let's make sure it's still good. Yeah, it looks like it'll be fine. I will open up, I think I have it in my history. Oh, bookmarks maybe? I guess I didn't bookmark it. ISL Multimeter IC? ICL maybe? Maybe that's it? Mic is noisy? I have shorts on. No, this is... don't think this is it, no. Oh, are you serious? Yeah, it did. Man, OBS is also troubled. Hello. Okay, yeah, that's it. Let's see. ICL 7107. That sounds a little bit more like it. Ooh, that looks a lot more like it. Excellent. I think this is pretty close. Yes, this is a pretty close part. So one of the things you can tell that this is a pretty close part with is that by probing out all of these pins up here, let's move that down, move that over. Is that all of these have a square wave on them, so that's how you know that they're part of the LCD outputs. And you can see, I guess it'd be oriented like this. All of these down around here are going to be square waves. So that one, and then that's the third one, and then it goes V plus. So I'm going to move the mouse. Can you guys see the mouse? I hope you can see the mouse. Maybe you can see the mouse. Move the mouse over here, and then so like this chip part right here is V plus, and then it goes something crazy, OSC1. Oh, it's the oscillator, it's not the power supply. OSC2, definitely part of an oscillator. Oh, sorry, I guess you can see over here, right? Here, got it, okay. So I can probe, oop.
there's the oscillator, there's the other oscillator. Oh. Let's see, can you see the scope in this? Yeah, kind of. Point is, if you start probing around, you can kind of tell that this is totally the same sort of chip. It's not exactly the same, I don't think, but it is pretty close. So let's see here. So this is common right there. And then, I don't know what that is. That's something. Yeah, okay, so these are fairly low voltages right here. Anyway, so let's take a look at some of these. So the ones I really care about are near the A-Z and buff and int pins. And let's take a look at, real quick, an example of how this works. What happens is there's an auto zero phase where it zeroes out the integrator. And then it's allowed to integrate for 1,000 ticks. So that's whatever voltage or whatever whatever you're reading on the pins integrates over this time. And then over the next 2,000 ticks, it goes and depletes it. Now, as soon as it gets to 0, then we know that's it. There's no more signal. And so a high voltage would integrate very quickly over this time and take a long time to deintegrate. Sorry. The part number for this is the ICL 7106. Now understand, this is not actually an ICL 7106. It's just like an ICL 7106, but it's close. Anyway, so you have the deintegration phase right here, and if it's a really small signal, it'll go boop, just barely integrate over that time, and then deintegrate real fast. Now, this is a really, really simple way, really, really cheap way of doing an ADC, and it's also astoundingly accurate. So that's how these multimeters can be as dirt cheap as they can be, and be incredibly accurate. It doesn't matter if your clock is way off. It doesn't matter. There's just so many things that can be just totally bogus, but because of the way this works, it'll just give you the right answer almost all the time. I mean, I don't understand the ins and outs of how it really works. My dad tried explaining that to me at one point, but I just didn't get it. Let's see here. I think we should probably now find the pin I care about, and what I think I'm after is the buffer out pin. Buff, maybe. Whatever. Let's go back to probing around in great detail. And move this back over here. Okay. The line is not going to be linear in reality. No, the line should be pretty accurate. It's a very strange ADC topology, but it works surprisingly well. Okay, so here, you see the 3 different phases coming out, and here, where is it? Here, okay. Come on. Hard for me to hold this. Hard to get this to somewhere in here. It'll start syncing. It's hard to show. There, maybe that'll be a little bit more clear. Can you guys see that clearly? You see that it's at 0 for a while, it integrates, and this is actually, I guess, axes flipped, so down is the integration phase, and then the disintegration phase is what happens later. So, if I take this and I reduce the voltage, you can see that the total length of time that the thing is on is less and less. So the angle of the first one is less and less steep, and then the angle of the second one remains the same, so the distance changes. And so right now it's in voltage overload mode, so it's going to go a little bit wacky. So it's back to 10 volts, so that's nice in the middle. That's going to be really hard to get an accurate reading off of, though. So the... wait, forward it to 7. I don't know what you mean by forward it to 7. Anyway, so it's going to be very hard to get a precise reading off of here because I don't know when it starts going down and when it starts or when it stops coming up. It would be very hard to calibrate something to read just that. But if I go one pin over, I can see this. And I can see this as being the points in which it would be doing both of those things. So let's try to synchronize this. Let's see, get a little more detailed. Okay, so we have the first phase where it's really low, we have a middle phase, and then a high phase. So let's see what happens when we change the voltage. So now it's low for a specific period of time, and it stays mostly in the middle. And as we raise the voltage, let's go back low again. Well, I'm going to have to tweak this here. Okay. Oh, come on. Oh, it's really hard to see what's going on here. Okay, so it starts there and it goes back low there. Now let's reduce the voltage. Hello? So you can see the length of time that it's low is longer and longer. And no matter how long it is or short it is, it looks like it returns back to low at the same place here. So I guess we should be able to measure the length of time that the pulse is low. Let's see if we can get a better reading on this. So it's just that little bit of time there, and as the voltage goes up, that length of time gets longer and longer. Okay, so what I think I want to try to do is have some sort of thing where I might be able to have a comparator, and I did just buy a comparator, and be able to cut it off right there and see how long the length of this low pulse is. That should be able to give me what I need in order to determine it. Now, it's a little bit scary because the voltages here are so tiny. Let's see. So that's 1, 2, 3, 4, 5 divs, and at 20 millivolts per div. Actually, it's much less than that because this probe is right now in 1x mode. Let's see here. So it's there. That's a couple divs at 5 millivolts. So we're probably actually talking maybe about 20 or 30 millivolts of clearance. So that should be enough for a reasonable comparator. Let's just compare that to what ground is. So ground is there. You might be able to just get away with doing a really terrible thing. Let's just give it a shot. Let's just go plug this into a comparator and see what we get. You know what? Let's just go whole hog.
I'm going to go back here. I'm going to go point this at me. Yeah, scope probes will affect measurements. I don't know. Oh, are you serious? No, it didn't. It's the mic died. Yeah. Come on. I just do that. Hello. No, let's try.
Whatever. Okay. Let's get this out of the way right now. So I had to admit, I had a while to think about this. I had a while to think about what it was. Well, you know what actually we should probably do is change the bit rate. So that would be 320 by 240. Okay. Should be fine. I had a while to think about this. I was aware that that's kind of how the thing worked as of this week. So this wasn't done completely unprepared. I did have time to go make a DigiKey order to order a specific. By the way, be careful when it comes to buying multimeters that look like these. Be sure to buy it and open it and make sure it's a good multimeter before you go buy 20. Yeah. I meant change the resolution. So what I'm going to do is I'm just going to go in whole hog. I'm going to just go design a board with an ESP on it and a comparator, and hopefully we'll be able to somehow get this junk working. Hardware, KiCad, new. You guys will not get to see how all the different versions of the ESP localizer. Sorry about that. So first we'll need to make sure we add. Uh-oh. Oh, what am I doing? Sure to add all of these. So I should probably leave this up. I don't remember which one. I went to DigiKey and found the cheapest one. I guess I should probably look at that. By the way, DigiKey is an amazing company. What I do maybe every other week is I make an order to DigiKey at like 8 p.m. on Thursday night, and it somehow magically comes here for very little postage because it is a USPS delivery system that I believe in. It's one of the few parts of America that still actually functions. Anyway, I order it at 8 p.m. on Thursday Eastern Time, and it somehow gets here on at Saturday every single time. Anyway, let's get this thing open. No, I'm quite Christian. Though I totally have a thing for the Old Testament. Stuff, more stuff. Yeah, I get lots of stuff whenever I get stuff from DigiKey because, you know, most of my, like, actually all of my disposable income, and yeah, basically goes to DigiKey every week. I do a lot more experiments that I show you guys. I only show you guys things that I'm pretty sure are going to work or have already worked. So let's see here. That's a blood oximeter, which I'm hoping will work. Some random stuff. MOSFET. LDOs. Optical sensor. Comparator. MIC 7221Y. Okay, so you have a good point. I should have chosen a comparator that has a an NFET. But let's see, what does this one have? Oh, 7221. Whoops. Okay. Well, it's not JFET, sorry. How much current does it use on the pin? That makes me a little worried. Mm, 2 to 10 microvolts, so, or millivolts, so we might be okay. Whatever. We'll just try it. If it doesn't work, it doesn't work. Let's see here. So yes, let's go add all the libraries. Let's go add an op amp. I think I actually have an op amp like this in here somewhere. That's not it. Wait, oh, this might be it. 6001R, is that right? I don't remember the pinout for a SOT223, or SOT23. You guys see all that? What was it? SOT 23.5. Let's see what that one looks like. 1, 2, 3, 4, 5. Let's see what the Micrel says. 1, 2, 3, 4, 5. That's good. So 1 is out, 2 is V plus, 3 is in plus. So let's see if that matches. 1 is out, 2, oh, that's all wrong. Let's see. Do I have another one? One is out, 2 is V plus, 3 is out, no. 1, nope, that's wrong. Oh man. Whatever, we might just have to make one. I've been so spoiled recently by all of the parts already having whatever, the thing I needed. Okay, time to make a new part. Oh, what have I done? I could do that, but then it gets all messy. I can just come over here, and one thing I really like to do is I like to make my schematic component look like the part, because that way I can have an idea as to like the way I can use the part to make it all map out. So 1 is out, V plus, V minus. So 1 is out. And so what I'll do is I'll actually make the place in the schematic where the pins go match real life, and that way I can really make it work on a one-layer design. So V plus is pin 2. What have I done? Getting kind of tired. It's too early to be tired. 3 is in plus. 4 is in minus. And 5 is, wait a minute. V minus. Boop, boop, doop, boop, boop, boop. There we go. Yeah, the idea is the schematic representation should be similar to the layout, I find. A lot of people don't like that. I think that that's kind of a foolish thing to do, because if you think about where you're going to be routing things in the schematic capture phase, it makes it so that it's the wires come out in more sensible places, like when you're wiring them up to a microcontroller, than if you hook them up to banks. Oops. Export. Electrical KiCad. Actually, you know what? Let's add that there. Okay. Done. It says library, add, KiCad, modified. There it is. Okay. Comp. Okay, there's that. Let's add an ESP12E module right there. Let's add, that's a good one. AP1117, nice little voltage regulator. Oh, that's not what I want. I want that one. No, wait, what? Don't want that, I want this one. Oh, bums. I don't want that one. Let's see if reopening it'll work. P1117. This one. No, go away! Regulator. Maybe they have the right one. Oh, hey, look at that! They made pins 2 and 4 the same. That's fine. We're fine. Okay. Let's see here. Layout will be... That's good enough for me. Looks like it lines up to the right pinout. Footprint. Oh, hey, check that out. It already came out with the right pinout. EXBA. Actually, nah. Let's use a 1206. Let's see. 2 of them. Actually, what I'll do is I'll edit this one. And we'll wire that into GPIO2 and GPIO1. Those have got to get populated, and those have got to go to... Let's see, what does the picture look like? I guess that's a good... Back up, you guys can see the fire.
let's put on a 3.3 volt output. Let's put on our 5 volt input, and it's not going to be 5 volts. We'll make it like 9 volts or something like that. GND. So we'll be using the battery to power this. So this is going to be horribly inefficient. But this just has to work. It doesn't have to even be good. You know, it doesn't even have to work. So let's just pretend here. Let's say 10K. 10K. Let's wire GPIO 15 to ground, because that's just a convenient way to do it. Even though you really should use a resistor, you just don't have to. Let's see here. Let's add a con... Hey, con 7, sure, whatever, that's fine. That's a good number of pins. It's a fine number of pins. Let's see, what is a good pin out for a con 7? Header. Is that good? Ah, that looks a little wacky. Let's see if they have a straight up one. Ooh, there we go. Oh, that looks good. Ah, that looks like a spectacular thing to do. Let's use this one. Okay, so that one is called whatever that long name is. Footprint. Let's call this PGM, etc. Let's wire it up so it works out. And this is why I like my schematic to match. Let's just wire these on through, why not? I really want to expose GPIO 0. 6 and 7, that can totally just be power and ground. See, what would be the easiest? I think it's easiest if we make the ground here, probably. And power here, maybe? Maybe? I guess. I don't know. So there's that. Let's see, let's add a footprint for the ESP. What is the ESP's footprint? Can you guys hear me okay? I mean, I know I'm just mumbling to myself, but... I mean, I guess you guys can hear me, otherwise people would be complaining. No! Do I not have it? Preferences. Manager. Ah! Please work. Yeah! That's not good. Let's try opening this again. Oh, it doesn't exist. I should have read the error instead of assumed it wasn't my fault. As soon as I read the error and I realize it's my fault, I can actually do something about it to fix it. One other thing is I do like to make my schematic areas a little bit smaller. That way, when I go to print them, I don't have to deal with huge PDF or PostScript files initially. Always on space. Yeah, it's too hard to leave that always on top. Hey, ESP12E. Perfect. Let's use you. Copy. Paste. Paste. Let's not use the ADC on here. Let's just, I don't know. Let's have some random solder points that I can use. So it's called an SMT pin 0.1. Okay, let's just expose that. Heck, while we're over here, let's expose 3.3 volts. And while we're also over here, let's also expose ground. Okay, so this guy here, we're going to have to give him ground and some voltage. Let's give him the full-on... Well, actually, let's just expose that pin. That's too far over to the other side of the chip to route it, I think. We can try, though. No reason not to try. Okay, so that's going there. Now I need to look up... Oh, microphone broke again. Hello? 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 That's the right microphone. You know, let me up the volume on that other one anyway. Hello? Hello? Hey, that looks better. Huh. Trying to find somebody I can select to be a moderator since I don't have anybody else who's I know personally on. Where is he? Lucas, I've seen you in a lot of things. Does anybody in chat have a problem if I make Lucas a moderator? And Lucas, if you can say hi so I can easily just make you a moderator next time, that would be cool. Okay. Some VCC over there. Let's throw on some caps. Actually, it looks like I might be able to make this work with 0805s, which would be great. So now I need to do I need to find out which pin actually, you know what I can just do here?
One of these... Duplex I squared S. Ah, there we go. Let's go and clone this. I'm going to close that. Yeah, it seems Lucas is not on the ball. I'll buy that. Electron Ash, are you up for doing moderator duties, if need be? Let's see here. I am looking for I2SI data. That one. What is I2SI data? Huh. Huh. It's got to be defined somewhere. Where is it defined? Here. MTDI. MTDI is GPIO 12, so we will route the output of this into GPIO 12. That way I can use I2S to get a detailed picture of what's actually going on with the ESP. Okay, so let's go net this out. Oh, you know what I forgot? Add some capacitors. This one a 0.1. Whatever. Single, that's going to be fine on the 3.3 volt rail. Boop. Okay. Let's go over here now. Yeah, I know the fire's dying. Be fine. Be moderator until you need to go. Okay, let's go add a little bit to the fire. So you can still see the fire if I back up some. Okay, so let's delete all the junk I have on here now. Delete, and let's netlist it in. Okay, there's that. Oh, you know what? I think I forgot to set the... oops, since we're going to be printing this board right now, let's do this a little bit easier to print, so there will be less of a chance for error. 1.5 track width, 1.5. So right now I'm just making all of the pads this nice little thing I can solder to easily. Ah, what have I done? I keep messing that up. Let's make this one a box. You know, just 'cause. That should go on the other side. This thing should go here. Be up a little bit. Whatever, we don't need no grids. Ain't nobody got time for that. Ah! What is it? There's a way to do this. Anybody remember off the top of their head how to switch the mode to shove? Is that it? No? There we go. I love the auto router. Not really an auto router, whatever it is. I love the interactive router. I love the interactive router. It's so nice. So convenient. Doopy-doo. How are things going? $20 to add BLE Wi-Fi? 20 bucks? No way! Dude, ESPs, boxes of them. Electro Dragon. They're $2 a piece. Yeah. Whatever. Oh, you know, I do need GPIO too. That's what the LED on the ESP is hooked up to. Oh, man. So I can't get the ground over there. So if I switch those two... I don't want to do that, though. If I put the ground on the bottom... Can I fit that through there now? Will that fit? Oh man, it's so close. Yes, yes! Ha ha! Sailing on over to the east side. Okay. Oh wait, that's not... I didn't... Oh man, that's not even what I needed to do. What was I thinking? Or actually, wait. That is what I want to do. So I can go U, delete, ground. Bingo! There we go. I can put this little guy on here. That's the wrong one. Here. How's the chat going? You guys are having fun, aren't you? No, I don't. I still think that the ESP8266 is going to have its place. By the way, if any of you guys need ESP32s, just the raw chips, because you want to do your own stuff, it's totally okay to ask, and or just straight up buy them from my my eBay. I have express permission to sell them to hobbyists. Okay. I forgot what the package name for the SOT23 is, so... Oh, it's just SOT23.5. Okay. Look at this chip. All of that stuff is what it's doing. Okay, so that goes there. It's there. Let's put that one there. Let's also name these. B plus. Out. Gurned. Three V3. ADC. N minus. in plus. Oh, you know what? I'm also going to need to get a resistor on the output of this because it is an open collector. If there's nothing to pull it up to 3.3 volts, it's not going to go. I could configure the ESP to do it, but the ESP's pull-up resistors are really weak, so don't want to do that. Let's see here. Okay. Yay, everything looks nice and labeled. We're not going to be doing a silk screen, so that should be fine, but... Hooray! Hooray! Put that there. 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 How is this gonna work? Oh, you know what? I never hooked up V minus to ground. Oh, I did. Wait, what's going on there? Whoops. Anyone remember how to... Oh, there we go. 5. One of these does, like, load it to the board or something. What is it? Anybody remember the hotkey for that? I don't remember the hotkey. Some way of just making it update. I don't think I've ever had to do that. Does anybody remember how to actually go tell KiCad, yo, make this thing like update in the... Looks like it worked. Hey, check it out. I'm going to be able to route that around the board anyway. Won't need to pull 5 volts from somewhere else. Okay, let's draw some markers on here so we know what's what and we don't blow things up. G and D, so we don't forget that. Oops, that's a little big. How am I going to fabricate the PCB right now, you ask? Well, just hang on, you'll see. Let's just call it the 9-volt bus, even though it's called the 5-volt bus, because, you know, I heard you like buses. So the next one up is GP0. And I think it goes 4-5 RXTX. Okay. You go switch back over to 25 mil for the most important feature. And add copper. Little ichthys, as is on all of my boards. Let's go fix that. I plus. Oops. I minus. You just have to change the design so the vias go through all the layers. And yeah, definitely. Definitely make it so that your vias go all the way through the board. Hidden vias are a pain and cause a lot of problems in the long run. Okay, looks like we're getting there. Let's go add the board outline layer. How much time? We're an hour and a half in. That's pretty good. That's not there. Let's do it here. Oh, that's a little depressing. You know what, let's isolate that. Yay, that looks good. I guess alternatively, I could have just, well... Nah, let's just leave that as is. Ferric chloride is not messy. Ferric chloride is the way real people do real circuit boards. Okay, I don't know. I'm just being a jerk now. There's a lot of ways that it can be done. I've tried several others. Ferric chloride is definitely the easiest for me. Okay, this looks almost ready. Let's see here. Take that on in. Yeah, let's just double check it. Pull up some resistors here. Whew. What's going on there? Not sure what's going on. Oh well. Should have 3.3 volts disconnected, as I do, but that's okay because you can just short through the chip. No problems. Okay. Looks pretty sweet. Do you guys see any problems? Does this look like a pretty good, ready-to-go circuit board to you guys? That would be a pretty cool idea, actually. You know what? Whatever. I never thought about that. We could, SANJA 2659. I would be up for trying to forge these in the fireplace once we get a little bit further. I'm really curious if that would work. Let's see. Log, so it'll be ready. Yes, Lucas, when we first hooked it up, we do know that the ground there is virtual. That should be okay. Yeah, I know it should be a ground plane under the ESP. It's not. It's not hooked up to ground or anything. I don't know. I don't know about that. Let's just not... I don't know. I've used ESPs this way. It'll be fine. It'll all be fine. Okay, whatever. If it's wrong, we'll just deal with it and it won't get done. Plot. Postscript. Plot. Okay, open with GIMP. Engage. Actually, you know what? I feel like printing more circuit boards today. First of all, 1200 DPI, grayscale, weak. Okay. While that's going, git clone. Nope, wrong board. One layer, that's what I'm after. I'm not going to actually put together the ESP32 one-layer board tonight, but I'd like to give it a shot and see if it works out. Okay. Yeah, GIMP handles PS files. That's the best way to export. Close some things here. Yeah, so on the back side of the board, on the ESP12S modules, there is a ground pad, and that really should be connected to the system ground. But on the 12Es and 12Fs, they don't have a pad there, so it should be grounded, but it's not that big of a deal. I guess I should just start going for it. Writer. There's a little ichthys. This one. Ichthys. Looks like it should be good. I'm always nervous whenever I do stuff like this because it's so easy to mess up. Whenever you print one circuit board, print 10, because you know you're going to mess them all up. By the way, I'm holding the Alt key to move the pictures around real nice and slow. Make sure the resolutions are about right for what I think they should be. Yeah, that's about right. Okay. Let's see, what are people talking about? Okay. Let's call this to print. By the way, I actually, every time I print circuit boards at home on my other account, I save it as to print and then a number. And the number kept going up, and then I had a crashed hard drive, and I never backed up the prints. So I think I'm up to about 200 prints at home now. I love printing circuit boards at home. Oh no! Where'd my printer go? Uh-oh. That's not good. Disappeared. Hey Christoph, if you're up for doing more work on ESP82XX, I really think there's a lot that can be done there. Hold on, guys. I'm sorry that I can't show you. I'm typing in password stuff, trying to figure out how to get my printer stuff to work. Does anybody remember off the top of their head what group I have to be in order to configure cups? No, Epson printers are not evil. Epson printers are fine. There's nothing wrong with it. I'm going to show you an amazing printer that's even better, though. And it is, if I can find it, a Phantom. It is really cheap, though. What group? Yeah, as long as it's not an HP, I'm fine. What? No, hey, come back. Oh, man. Cops. What's going on, computer? No, I'm on Linux Mint. Yeah, oh, user ad. Yeah, that works too. It turns out I'm in the group for it, so I don't know. Aha! Ah! Aha! No, do I not have the driver? Oh, man. I could have sworn I just printed to this a little while ago. I did not plan to have to do this. No, the printer's already got Wi-Fi. Ooh, I haven't checked Twitter in a while. Oh no, 8 notifications. Okay. Somebody's been working on trying to get me the other videos synced up, so... Yeah, I have an old computer. Hey, look at that! The Phantom site has support for straight up Ubuntu. Maybe we should consider buying them. It's a little scary to just run a file like that, but... Who is it?
Hello.
Hello. Roommate Inverse Phase just came home. There it is. P25W. Resolution 1200 DPI. Collated. I don't know what that means, so I'm turning it off. About to print some circuit boards.
Nice.
If you don't, I mean, I guess you could help me with the laptop, moving it around soon, I guess.
Well, the question is, I still need to dump some crap out of my storage unit. Would you rather I use your truck now?
Yeah, do that. Here, let me. Oh, I don't have my keys.
It's hanging up, I think.
Okay, yeah, go for the keys then.
Okay.
Set default options. Density. Dark! Yes! Toner save, off. Negative film, off. Rotate, off. Paper. Paper type. Transparency. Actually, hey, Christoph. Christoph, if you're still here... Oh, there you are. I'm going to just make you admin. Sweet. So first it's going to print with, let's see, how am I going to do this? I'm going to unplug from power. I'm going to leave the Ethernet plugged in. I have to... Okay. Can you guys still see me and everything? It's still working? I think it's... Oh, it bums. Give it a second. So that's not working. Hey! There we go. I also have a mountain of Cat 5 cable right there that's all coiled up. So that's how we're going to go upstairs. Seems like a really bad idea. Let's put this down for a moment.
Whoops.
You're still. This is an issue.
That's fine. I'm not going to go any further. Okay.
No, it's less of an issue. I might relocate the toolbox and the chainsaw temporarily.
Okay.
With you.
Open the garage. Put them in there.
Okay.
Ah, there it is.
Okay. So you guys can kind of see this. Sorry. So you guys, can you, everything's still working right? So I have two copies, and when you overlay them, it makes darks dark enough that it doesn't be awful. Just printed transparency. By the way, that is a $37 laser printer, and it actually works, and it comes with a lot of toner. So don't spend more than like a couple bucks on your laser printers. Oh no, I've hooked it. Oh, I'm sorry. Switched mics. I think in the future,
These is I'm just gonna disable the hello. Okay, there we go. I think it's about time we make the resolution a little bit better on the camera. So somebody had told me recently, like, hey, you really should consider using a an LED for your etching process, and I was like, I don't know, that seems dumb to me. But I actually found the Riston manual from DuPont, and they were like, yo, you should be using this much light, otherwise you'll get really inaccurate traces. And I'm getting pretty inaccurate traces. I can't believe it. They actually specify distance and strength for the wavelength that the DuPont film cares about for this light, and it's like maybe 1/10 the brightness it should be. So yeah, I'm gonna go try some LEDs. Move that over there. See if you guys can see most of what I'm working on. Okay. Try to get a little bit more light in here. back. Got that, got these, this, make sure I have enough gloves. I do. Let's use this one. So first, get some water on it, clean it off with some nice steel wool. I guess you can't see that. Hello. What are you guys saying? I don't use hot water because it makes little itty bitty bubbles. I also realized I need some baking soda, so I will be right back. Do you care about water? Because I don't. I live in Baltimore County. Okay. So a lot of people complain about me using too much water. My average daily consumption is 197 gallons every day. And my total bill is $47 for 3 months. Water in Maryland comes from the sky, the ground, and anywhere else. They do, basically, if I don't use it, it just goes into the ocean. So, why not use extra water? Okay, let's go in. Got some just on here. Oh, I wish I had good eyes. Oh, there we go. Oh no, I'm not going to forget gloves. I have gloves right here. Don't worry about that. Amazon Basics is the best. If they have it, man, I can't even beat it going to China most of the time. I've always wondered what that sound is. I've never found out. Whoa, I guess my mic's a little loud here. How many Chinesium ingots would you rate the printer? The Phantom? 5 out of 7.4? Did you lose Prime? Oh, it's already done. Okay, that's fine. A little blemish in the middle, but whatever. Okay, so that's a... I have to turn out that light. Sorry guys, don't want to have too much light exposed on the film. It'll be bright soon. Right now I'm just going to cool it off some. What happened that you had to lose Prime? I'm a child of Amazon. That would be awful. Nope, CNC for PCBs is awful. This would take much longer on a PCB, especially considering how much detail work I wanted to print. And I wanted to print several copies, so it's a lot easier just to print a whole bunch of copies on there. I forgot to do something. Is it cool yet? It's still too hot. I actually did try Riston and DLP a little while ago, and I shot a DLP projector that worked at basically point-blank range, about 3 inches away. And it took about half an hour, and the boards it made were just awful. So I'm never going to mess around with DLP and Riston again. I'm putting some 3-in-1 oil on. Now that that's there, I can at least expose some light so you can see what I'm doing. Manually squeegeeing all the bubbles out and getting it as flat as possible to the surface. Okay. Next one on. One more 3-in-1 oil. Didn't use enough 3-in-1 on that second layer. So there's a lot of dust on it. Oops. Should have cleaned off that dust first. Oh well. YOLO. Yeah, they say in the document that it should be around 380 nanometer or less. So I just bought a 100 watt 385 nanometer LED. I splurged. I know it was a lot of money, but you know, got to deal with it. Let's see, what is the time? 4:45 from dark. Let's just try this. I've never done it this close. Or should we play it safe? Whatever. We'll just do it live. It'll be fine. Safety glasses. You guys see that? Kinda. I can't see right now. How many people are... actually, can you guys see how many people are... Oh, wait, maybe I can... $179 people. I would not have expected doing this during the Super Bowl would have been a better turnout. I'm totally winging this. I normally operate with the light up there. I might have some notes though about what... Yeah, I don't have any notes here from any of the times I did it on the bottom shelf, so this will be an experiment. I usually write down what my my processes were, just so I keep kind of a record as to what worked and what didn't. Although oddly enough, now I don't have a Sharpie. Oh, 2 minutes. It's definitely starting to turn. Makes me nervous. Because overexposure is like, gotta throw it out and do it over again. Ooh, it's definitely starting to turn now. I'm going to stop it at 3 minutes sharp. Well, okay, let's wait another 10 seconds. Or 5, whatever. Oh, that is glorious. I hope it didn't overexpose. You can see where it is exposed, it's purple, and where it's not exposed, it's kind of bluish. So, oh, you know what? I didn't even mean to do that. I was gonna switch this over to baking powder, whatever stuff, or washing soda. see, what was the last one I did? I didn't write the chemical. Oh. Wait. Nope. Oh well. Might be pure and natural, but the stuff is crazy. Totally makes your skin feel just awful. I'm pretty sure you're never supposed to get it on you. Super washing soda. Got to keep the water flowing to keep it hot. That is the fastest I've ever seen a developer happen. Almost developed. A little bit more. One of the neat things is that that's all mostly baking washing soda, so it's a really good base. So now this is already hot. Just make sure it's good. Makes me nervous I didn't get it all. So if you don't, it's a pain. Uh-oh, I'm almost out of ferric chloride. Good. It looks like the development phase worked well. I need another sponge. Oh man. Whatever. I'll just do it by hand. It'll be fine. It'll be fine. A sponge is really good for this, but the other thing is the water is still very warm, so this process goes a little bit quicker. I used to just drop this in a vat of cold ferric chloride, but that got real lame real fast. And by real fast, I mean real slow. I hope chat's not going bonkers. So a lot of people complain like ferric chloride's so bad and everything. But really, the small amounts that you'll use at your home are almost nothing. And you really can't pour it outside, that's true. And you really can't pour it down the drain, and that's also true. But that's generally not an issue because most jurisdictions have some way that you can get rid of your hazardous household waste. And that's really what it is. It's just household waste. It's very easy to just justify. It's like, yeah, it's for my hobby. And yeah, I only have 2 gallons of it every 6 months. And pretty much all of the local areas are just more than happy to be like, okay, yeah, sure, we'll take that. I guess you guys would want to see that close up, wouldn't you? Almost done. See that it's already starting to etch through. You guys see that? Kind of ish. It's not that I don't care about the environment, it's that I'm going to focus my efforts where it matters, like building nuclear reactors everywhere. Because it's the only green form of energy we have. I can't believe we're not trying to do it more. I'm so glad that they let us choose our energy here, so I was able to pick Constellation, which is, for my area, the provider that has the largest amount of power that comes from nuclear. This part's taking a little bit longer than normal. Not sure why. Almost looks like it's almost done. That's the FR4, or sorry, this is CEM1, I think it is, that's coming through. Give me a second here. So there are a few drops that I get into the sink that go down the drain, but I do neutralize it using the excess washing soda. Which is why I have that just chilling in the drain. Okay. That is done. Okay. I capture the extra ferric chloride and I take it to the dump so they can dispose of it properly. I forgot to put on safety glasses during that. I should have put on safety glasses. If I don't put on safety glasses again, guys, warn me and remind me. I shouldn't have taken off the gloves. This is the most amazing part, so I'm going to let you guys see it up close. Where is my acetone? Ah. Stupid safety keep kids out thing kept me out. Okay. Watch carefully. Now I can actually take off my glove. Fixing the tripod here. Oh boy, that's a little weird. Hello. Okay. Yeah, speaking of the UK, you guys get positive 20. I can't get positive 20. I'm sorry for yelling, but no, what the heck? I want positive 20 so bad. I want to try it on a circuit board so bad, but I have no way of getting my hands on any positive 20. Wow. I don't see any flaws. This is the best circuit board I've ever made. Better yet, you know what? I'm going to go try to see if I can find a microscope. Although, let's go back to the fireplace first. That way you guys can at least watch the fire while I try to find a scope. Oh, forgot to turn off the light. I do believe in conserving resources that make sense to conserve. Oh no! Fire has died. Okay, where do I have a microscope? Huh. I have not used my microscope in quite some time, so I don't know where it is. Oh, hey. So, one of the other benefits of these ESPs, of these multimeters, is they don't just turn off in the middle of you working. Like, I've used flukes, because I have to use flukes sometimes, because I actually need better multimeters than these are, and it just turns off. I'm like, I have to go, like, stop what I'm working on, go back over and turn it back on. This is stupid. The batteries on these things last, like, days, so why would you want your multimeter to automatically turn off? I don't know if I said this already. I don't know where my microscope is, so you'll just have to settle for looking at that close. Wait, how close will this thing focus? Apparently not that close. All we actually care about is this board up here. Oh, I did not know you could set the timer. I think I will start setting the timer. Do I really not have that microscope anywhere? That's really sad. I don't know where it is. Let's see, it's... It is not the multimeter from Harbor Freight. It is from Kelvin. They are very different multimeters, even though they look the same. I'm just cutting these guys out right now. I believe it's CEM1. At least I bought CEM1. It doesn't feel like CEM1. It can't be CEM1. It must be G10. I really like the CEM1 stuff. It just feels nicer and cuts like butter. I don't actually know where these came from. I think they might have come from Home Depot. Though Harbor Freight is a perfectly cromulent place to get your tools. One of the nice things about Harbor Freight is that instead of like buying your tools and having to take care of them, you can just buy tools for a project, throw them all away, and then buy new tools for the next project. And after like 30 projects, you still end up with spending about the same amount of money. It's like I don't actually throw away all my tools. I'm being a bit of a jerk. Okay, I guess I should do a bit of a recap on how this is planning to work. Inside the digital multimeter is a tiny wire that's like, or one of the wires internally that are used to charge and discharge the timing circuit on the module on the digital multimeter, and I plan to tap into that particular wire and try to monitor it. And then once I can monitor that wire, what's going to happen is it's going to go low for some period of time, middle, and then high. And I'm just going to look for just when it goes from low to middle and then low to middle. And hopefully I'll be able to time the amount that it's low versus the total pulse length and be able to get the exact value that would be showing up on the meter. Don't know if it's going to work though. Hello. Yep, it's an ESP12E. I don't know what I plan to do with a Wi-Fi enabled multimeter, but I also rarely plan out what I'm doing before I do it anyway. So I'm just going to put my solder paste back in the fridge before I keep moving. I sometimes forget it out if I don't. You can get Riston from eBay normally. Let's see, is that good enough lighting? Let's make two, because if you ever make one, they won't work. It's like it knows that By the way, if you do want to get my attention, make sure you @ lore me. Otherwise, I can only kind of glance at chat. Whatever, let's just do these two. Are you guys having fun in chat? I'm sorry, I can't really look over very often, otherwise things go slower. I'd like to keep things moving as quickly as I possibly can. Also, I cannot wait to toast these things on the open fire and see if it works. If somebody can you tell me how many people are in chat? Oh, do you have to get the wrist-on stuff off eBay? Or does the generic stuff work as well? I've never used the generic stuff. I've only used wrist-on. I don't know. So CNLore reads out the LCD is direct from the chip. The LCD, each one of the segments comes off of the chip, yes. I am sad that... Oh, Jernedge, is your multimeter less than $4? Because if so, I think I would switch to that. Hi, Jason Spriggs, and hi, Dylan. Hi, MagFest people. CNLore isn't watching post Arduinos. Arduinos are okay as long as they're made with an ESPD266. At CNLore 165. I don't know what you're referring to. CNLore, could you tap into the shift register of the display? There is no shift registers on the display. If there were shift registers on the display, I assure you I would have done that in a heartbeat. I had really been hoping that there would have been some way of quickly getting that data out of the system, but I looked and looked and did not find it. So I am assuming that there is no easy way of getting the data off of that chip, short of wiring up to each one of the segments, and I really don't want to deal with that. That's just not something I would find enjoyable. Okay. Oh, 165 people. Cool. That's a lot of people here, especially for the middle of the Super Bowl. Actually, that reminds me, the Super Bowl, is that still going? Who's winning? I don't even really know who's playing. I know New England, somebody else. Actually, how many people in here are Americans that should be watching football and are not watching football? Do you genuinely decide to solder those in the fireplace? Consider at least shielding the board with metal. No, I will be soldering it from underneath. Ooh, that's not good. One thing I've definitely found is that the surface mount parts, like that's one of the reasons I really like a hot plate to solder, is because when you solder from underneath, it doesn't roast all the chips. It's harder to control, but I don't know. I have had better luck with temperature sensitive parts with a hot plate than I have a toaster oven, which is unusual. Even I find very strange that could possibly be the case. But so far, it's seemed to have been pretty common. Let's see here. What is this? Galvanized, 26 gauge, zinc plated. Okay. I have a sheet of galvanized metal. Lore's Falcons are... Whoa! That is a lot of points on one side and not the other. How much time is left in the game? That's really serious. Are they gonna go, like, end it early or anything? I've never actually used this for a hot plate. I think it's steel, so it should work. I don't know. I probably should be using aluminum or something. Oh, bummer. It's funny, a bunch of the people at my church are rooting for Atlanta, and my pastor's rooting for... What's the other team? I don't remember the other team. And so, I don't know, it's kind of funny just the interaction they have between them. Although, to be fair, my pastor didn't mention football at all during the service, so I'd say we're doing okay. Man, I wish I could get that closer. I'm trying to remember which one of those is a resistor. Those two, maybe? Capacitor. Oh, man. I think we're gonna have to go over the 4-hour limit I was hoping for. Makes me sad, but still says it's recording, so that should be okay. What's going on? Oh, that should be over there. Does galvanized steel release chemicals when heated? Does somebody mind checking that for me? Because if I'm gonna die, I'd rather know that so it doesn't happen. Somebody at sea and lore me with whether or not... yeah, there's still a lot of reasons to use the ESP8266. Much simpler SDK, much easier to use. Only thing you really should switch away from the ESP8266 for is if you want to start doing complicated things. Anything that takes a lot of RAM, stuff like that. But if you're just going to make like your little garage door remote controller, keep it. It does when you weld. Okay, well... Okay, well, I'm not going to be doing this on galvanized steel. I'm very glad that you guys were all here to tell me not to do it. Oh, there's a lot of people. Metal fume fever. Chimney should suck everything up. I'd really rather not take any risks. I'd rather not use a baking tray because I'm probably going to destroy the underside putting it on the fire. Oh, I hear somebody calling my phone. Give me a second. Somebody said that there is a button that you can hold to disable turn off on the flukes. I will look that up in the future, because that is an absolutely critical feature that I need in my life whenever I have to use a fluke, which is rare. Oh, yes. Time for the star of the show, our comparators. I don't have anything made out of cast iron, but even if I did, I really would not want to put circuit boards on it. I probably have an aluminum sheet somewhere.
Okay, let's put on the ESPs. One thing I usually do when I do surface mount, if I can think about it in time, is I start with the smallest components and then I work my way to the larger components. Just has always seemed to work out easier that way. What are you guys saying? Oh, the mic switched? I'm sorry. Oh, my battery is also critically low. Let me go plug in. Testing. Oh, there we go. Okay. I'm currently looking for something to put the parts on to put in the fireplace. Oh, I don't see anything. I will be right back. I found a sheet of super thin FR4 copper, or copper plus FR4. This will be what we use. And if this sheet gets too hot, then, well, we're doing something wrong. Who am I kidding? We're always doing something wrong. Heat gloves? No, plastic should be fine. Yeah, I really should be wearing some sort of glove. That's... we'll go get some gloves. If I can find them.
Do not have heat gloves. Do have gloves that are wrong, but might work. Where's... Hey, Axle Crusher, can you say something so I can mod you too? Oh, there you are. Yes, I remember when I melted the carpet. That was with a stainless steel sheet. Ooh, that is hot. I think it's going to be really hard to get even heating on this. There, maybe? It is really hard to hold too. I really should have found some oven gloves, though I don't know where any are. Put that there, maybe? Can somebody take a screenshot of this? This is ridiculous. Maybe I can? How do I do that? Is there a button? No, I don't think there's a button. Oh man, I can't read everything people are saying. Oh, pliers, that's a good idea. Oh man, they're all the way over there though. Okay, hold on. This is not working nearly as well. I thought it'd be reflowed by now. Oh hey, it is reflowing. Yeah, it's not even though. If I do it up here. Something about this feels like a really bad idea. Don't know why I didn't realize that earlier. Why won't you reflow? Oh, nope, it's going. And another one didn't quite make it. Yeah, let's not do that anymore. I think it's time it goes over to the soldering iron. Although I can't easily. That's not too hot. I'll just bring the soldering iron over here. And we will also arrange it so you guys can watch the fire again. Not using a fire poker as a soldering iron. We had enough dumb ideas for tonight. Oh, this other one did actually get fully done.
Okay. Let's use our multimeter here and determine if there are any shorts that shouldn't be. That's good. That's good. That was weird. That's good. No, that's not good. That's really not good. Both of the boards have a short. Why? Why? So where did I put the other boards so I can see if they have the short in the design? You know, we're going to use the terrible method to determine where the short is. Current up, voltage down. Now I wonder if it was in the design. I also forgot where I put my boards. I had them a moment ago.
Boards, where are you? Oh yeah, okay. Okay, give it a shot. I feel like I must just be doing something obviously dumb. Like, that's such a dubious connection there. Why did I think that was a good idea? Also, probably should shrink this back if I'm going to go look at circuits, or get it on the side. Just worried that that right there, just, it really seems dubious. Going through there. That might not be it, though. Also, there's a short there. Why would they both be shorted? Let's see if they're both shorted by about the same amount. Yes. I'm right now applying a couple volts between 3.3 volts and ground. This supply is pretty bad, so maybe about 2 amps there, but I don't know where the current's going. I think I'm gonna have to go find the oh, boards are up here. No, it's open on the actual circuit board. Yeah, I think I'm going to pull it up. I'm thinking fire reflow is not the best thing. I did. I checked the caps. Where did the tweezers go? Oh, they're there. Yes, I'm definitely going to check that eventually. I don't see anything obvious though. Well, let's first probe out now. Nope, it is just fine now. That's good. Okay, I will probe the ESP. I don't know. ESP's not shorted either. Well, I will try to manually solder a new ESP in place. I'm also going to clean off the pad some. Good. This might work. Tell you what, I'm going to just reflow this one and see what happens. I wish there was an RS-232 pin. Looks great. Now it's fine. I don't know. Let's see if it works. If it works, then I'll say that you could potentially maybe reflow and fire. I don't know. It's a bad idea. I'm gonna go get an RS-232 programmer. I'll be right back. Okay. Hello everybody again. Serial's like USB. You have a 50-50 shot at getting it wrong 100% of the time. Which is basically 100% a chance to get it wrong every time. Hey Chris, I'm going to try to pull the ESP82XX for this. Because I do want it to have a web interface. If you guys want to see how the ESP82XX stuff works, go for it. Here, you can just watch it. I don't want to do that. Gotcha. Sorry. Oh, I see what you're saying. Yes, we'll fix that right now. How's that? Chris, it'd be really cool if there was a way that I could just say, like, make, and then make this current project that I'm in an ESP82XX project. That would be super cool.
What am I missing out in chat? No, nothing like a captive portal. You just have to visit 192.168.4.1. Okay, that's not working right now. Let's try switching the RX and TX and see if my thing about you have a 100% chance. Yep, 100% chance of getting it wrong every time. Let's also change the baud rate. How do I do that? Much better. Okay. Let's see. Is this going to work? Let's see if this kills the stream. Can't even type my password right. Are you guys still around? Did I kill the stream? Looks like it's fine. Let's see if I can also connect to the ESP. Let's also close some apps. Okay, whatever. That's not good. Oh. Oh, I'm not doing that. Let's also get rid of that noise.
What am I doing wrong here? I must be doing something wrong. You actually don't need the RS-232 stuff to do the baud negotiation because the system kind of does that for you. Let's keep chat open while I do this. That's just fine. What makes the Kelvin thing here so bad? Okay, I have no idea why that didn't work the first time. It's working now. I think it's time I soldered on some extra little stuff so we can probe it. Ooh, you know what else I want to do? I want to find out if this one works. I guess it wasn't in all the way. Okay. So apparently that's it. It doesn't kill the ESPs to get them reflowed on the fire, but they also don't work real good, so... Huh. See, why did it just reboot? That's weird. It shouldn't just reboot. Oh, whoops. That's because the GPIO 0 is being held down. Okay. Ah. Okay, so that looks like that kind of works, but it's a little rough. Perhaps we should turn off sending trash. So one thing I found is that the ESPD266 is really, really good at honoring all of the 802.11 stuff, including like carrier detect and stuff like that. So on the ESP, right here, I'm sending AAA, which is just going to produce a mountain of noise on the RX pin there. And so I'd rather just not send any of that, and that will make it so that hopefully the signal will work a lot better. So let's try that right now. And what I'm actually doing is I'm holding the antenna with my thumb, and that attenuates the signal so that the system doesn't get the carrier or the carrier detect sense, and therefore will just kind of do the right thing. Meanwhile, that was apparently not the problem. Or is it? I'm not sure. Seems to have a bad day. Wonder why it's having a bad day. Are they both like this, I wonder? It was actually rebooting because it had run into a... hold on here, let's reboot that sucker. Oh, this one is definitely troubled. So at any rate, if you press and hold GPIO 0 low for a really long time, it'll kind of go into the safe mode where it... Oh, man. This is not going to work. Why is it so noisy? I don't know if it has a proper encryption core. I've never needed one. I have honestly never noticed any performance difference though with slower or anything when I switch over to Nope, nothing. Shouldn't have any problems. I don't know why, as soon as I touch it, it seems completely happy. That's a ping graph, and it's showing latency to the ESP. Right now, that's my laptop searching for wireless networks nearby. And as soon as I hold on to it, it seems pretty okay. But if I let go of it, it's awful. Let's see. I honestly don't know why. Let's try slowing down the I2S core. I have noticed that when you crank I2S, sometimes things get a little bit weird. So this is net burning, rebooted. My laptop should hopefully connect back into it. And I'm not sure, things might be good now? I guess they're good now. Okay, well whatever. Don't know what was up with that. Huh. Okay, apparently this one you can't crank the I2S bus at. Or something. Not really sure what. But that's okay. Let's see here. If I touch these pins, it should do something. I'm going to apply a small voltage. Not working. I should have broken out another pin. Made it easier to get a good ground on this thing. Whatever, I'll just solder that on now. think my goal for tonight should be a little bit more benign than usual. It would probably behoove me to make it so that my goal will be to simply be able to see the signal going up and down inside the ESP, or like coming from the digital multimeter. Once I get that, then it's a matter of writing some software, but it's probably gonna be a little bit too much work to get all that done tonight. Right now, just soldering some male DuPont connectors onto the probe pins here. I need an alligator clip for that because I did not think that through. Or will I? Okay. Oh, that's interesting. Ha! It's so sensitive. Can you guys see that? This thing is so sensitive, it's picking up the 60 hertz. Coming off my hand here. Yeah, that's 60 hertz. Yeah, I strip insulation with my teeth. So I actually chipped my tooth once a long time ago. I made a little notch right there that I can fit wire in and just pull it out. Okay, so that's good. Let's see, what voltage is that currently at? So if that's 3 volts and that's 0 volts, this is at not quite 3. Oh no, it is 3. Okay, that's good. So that's plugged into... Did I wire this to the wrong pin? I think I wired it to the wrong pin. I am probably an idiot. No, it says GPIO 12. I2S duplex. Do I not read it out or print it anywhere? Okay, so I don't even remember what this code does. I guess that's ETX and ERX. So this happens every time data gets shifted in. Do I ever look at the data in that structure? What am I printing? I'm printing TX, TX, RX, RX. So I really should see something on that RX pin. No, the multimeter does not. It's not actually a digital signal. It's a really low voltage, very weak signal. It's intended to integrate and deintegrate the sawtooth. Oh gosh, why is this not working? Let's dump that stuff because we don't need it. There we go. So actually right now, just so you guys know, I am net burning, so it's not... Why is... So I see in my oscilloscope signals going high and low all over the place, but in here it's always 0. Why is it always 0? It should definitely be reading in data. I have data here, BDRX. That's interesting. Let's see if I initialize the data to something non-zero. Does it fix it or does it keep it as it is? No, it zeroes it. Maybe I'm not setting the pin direction? Oh, that's weird. Now it's FF. That's really weird. Zeros. So maybe this is actually working perfectly and I just was too dumb to realize it. So let's see, if I hook it up this way, 0. If I hook it up this way, 1. Oh, it was working the whole time. I'm dumb. Yeah, I should have done that. You're right, Luke. I don't know what I was thinking. That's totally working now. Can you guys see the fire? Good, you can. Okay, so that part's working. Maybe we should come up with a way. Let's just, well, no, I want to come up with a way of actually printing out the numbers I'm getting in between the times. So I should probably actually... Wonder if it's, does anybody know if the I2S engine is MSB first or LSB first? So can I slow it down a whole bunch and then I might be able to tell? Is the Super Bowl over yet? Oh, that didn't work. I'm going to have to be clever about how I do this. So it's going to have to, I think we can look in here to get the data. curious what happens if I bump that up to 16. Will that still work? I want to keep things moving as slow as I can. No. Will that work? Neat. That's neat. Let's try slowing it down even more. Nope, can't slow it down that much. Is that the amount we can or can't? So that still works. Can I really not slow it down anymore? I actually just wrote a thing that can in Python watch the YouTube chat, so that might be feasible. Okay, whatever. Let's just try printing stuff. I wonder if I can print it out in the whatever you call it, the inside the interrupt, or if printing inside interrupts is prohibited. This is probably going to just explode in my face. You gotta reboot? No? Gotta have some extra help? Oh, there we go. Well, that looks like it worked. That's not what I would have expected. Huh. Does not look like it's working well. Looks like it's stepping all over itself, though. I don't know if any moderators are left. That actually looks kind of like what the scope is doing. maybe it's time to start probing the scope. Or probing the, whatever you call it, multimeter. So, recap for, actually, how many people are in chat? Or I can check, 113. Okay, so let's go over this multimeter thing since I went over it in the very beginning. Inside here is a chip that's kind of like this ISL, I don't remember, it was some chip, history, closed, ICL 7106. It's like the ICL 7106, and in here it has this buffering and this int thing that it integrates the signal over time right here and then drops it. But there's another pin that actually controls the integration of the signal. And my goal is to make that be the way I determine, like I'll watch that carefully, and hopefully that'll give me, to some reasonable precision, a way of telling what is actually being put out on the display. So I'm going to put about 10 volts on here, and I'm going to go probe it, and we will see what we see. So there's this pin here. Gotta crank up the sensitivity some. Actually, can you guys see that? Yeah. So one pin is kind of like a digital. Uh-oh. Okay. One pin does this integration waveform thingy that you can see in that sheet there. Let's see, does that make it a little more clear? Yeah. And it's actually inverted, so it's this thing here, but that's upside down. And then this is the thing that actually turns it on and off. And so what I'm going to try to do is use this as the thing that will like switch the meter back and forth to determine what's really going on. So I'm going to probe between 1, 2, 3, 4 and the multimeter ground. And what I'm going to do is solder those onto little wires here. A little bit shorter too. Let's make sure we didn't blow up the meter. Nope, still reading 10.98. The snoops are pretty high Z, so that should be fine. I'm just going to try plugging them in this way, and we'll see if it works. And if it doesn't work, I'll try plugging them in the other way. And actually, while we're doing this, I'm going to go probe this with the scope, because it'll be easier to see. So this is probably going to be nothing. I mean, it's something, but it's pretty terrible. Yeah, it's right on the edge. So we're going to want to measure that against something that's a little bit higher than ground, I think. Or wait, what happens if we just switch them around? Because there is a little bit of a band gap, or a little bit of a voltage gap in there. No, it's still the same. Is it still reading okay? No, it is not reading okay. Interesting. Oh, it's because that fell out. It's reading okay again. Maybe I should be using a variable resistor in order to tune the ground pin. Maybe that, or maybe I should be probing. Wow, that's pretty crazy. That's a big swing. What is that coming from? Perhaps I should be grounding the two of these things together. Yes, let's do that. That shouldn't blow anything up. Okay. Now let's see what it says on here. So if I probe that, that's high. It's also high. That's a little weird. That's reading all wrong. Let's see if I unplug my laptop. Nope, still reading wrong. Huh. Yeah, I'm sure there's a lot of RF noise, but yeah, I don't know. Oh, you know what? I'll bet you that the problem is I need to be getting the 5 volts from here instead of my laptop. So let's do that too. By 5 volts, I mean 9 volts. Also, I'm colorblind or something. There we go. I want orange or red. Those are all male, right? Yeah, they're male. That's the wrong side. That's good. 11.1 volts. Okay. Now let's watch it with the scope. Looks interesting. That's pretty close to what we want. I'm going to go reduce the voltage. So now it's nothing. As the voltage goes up, it goes down more. Huh. Ah, this is getting weird. Yeah, I'm thinking I probably should have a variable resistor in here so I can tune. What is going on with that? Why is the potential changing so suddenly? Oh no. The ESP, I think that's the ESP sending stuff. Yeah, oh no. Yeah. That right now it's little battery lights on. That's not good. It's reading the correct voltage though. I'm actually outputting the right voltage there. Oh no. ESP, are you dead? What have I done? That's not good. Ripple is too high. No, the watch, it's okay. It's just that the ESP is wrecking up the multimeter, the power in the multimeter. I think I need a bigger capacitor on there. Let me go see if I have any 1000 microfarad or something capacitors. I have a 330. I'm going to try to install it inside the multimeter. I would imagine these multimeters were not designed with an ESP load in mind. They're designed for the multimeter load, which is extremely efficient. Very low power. Still working? It's still working. Okay. Let's try plugging the power back up to the multimeter. Plug you in there. Hey, it's back. Okay. Now let's also see if it's totally wrecking up the power bus on the multimeter again. Still. No, it's not wrecking up nearly as bad. Okay, let's see. So if I decrease the voltage, yeah, I'm not really seeing any relationship between the voltage I put in and the digital out signal. Yeah, the ESP does have a common ground with the laptop. That is true. And the ESP has a common ground with the virtual ground inside of the multimeter. No. No, it doesn't. The ESP has a common ground with the actual negative side of the battery inside the multimeter. That's going to be really hard to troubleshoot with the ESP drawing all of that power all the time. Oh. I wonder if I can make the ESP's ground the same as the virtual ground inside the multimeter so I can at least troubleshoot this. So ESP is going to power. I put the wrong gender on there. I'm going to power it off my laptop again if I can get that to work. Then we'll just slap a battery inside this thing that's other than the 9-volt battery. I'm sure the ESP does not like the 9-volt battery being abused. Sorry, the multimeter does not like the battery being abused. See, it's still reading good? No, it's bad. Oh, that would wreck it up. There we go. Okay, so now I'm back on 100% laptop power. Let's see if I can probe these things out. Reduce the voltage. See in the scope it doing the right thing, but I don't see it doing the right thing coming off the yeah, it's definitely not doing the right thing coming off the little doodad here. I wish I was a better analog person. Good night, Electron Ash. What you missed is Charles is bad at analog and can't figure out how to make it work. Trying to find a funny little what do you call them? The trimmer pot. I'm trying to find a trimmer pot. I thought I had a trimmer pot. I just don't know where it is. Trimmer pots. Where are you, trimmer pots? pots, where are you? Trimmer pots. Hello? Trimmer pots? Trimmer pots? Trimmer pots? Trimmer pots, where are you? You're somewhere. I bought you a while ago. Trimmer pots. Trimmer pots? Trimmer pots? Trimmers. Where are you, trimmers? I paid money for you. Where did you go? Oh. Oh, wait. Ooh, promising. That's buttons. Found buttons, guys. I know you can't see this. Buttons are exciting-ish, I guess. But there's no trimmer pots. Where did the trimmer pots go? Trimmer pots. Seriously, trimmer pots. Where? Where could you have gone? Maybe I have them above my fireplace? Trimmer pots? Oh, hello, Caps. Let me see you there. Ah, trimmer pots. Yay, trimmer pots. Trimmer pots. Yay, trimmer pots. Who else is sad that the fire is burning down? I even have these marshmallows and I can't use them. Right now, the ground of the scope is hooked up to the physical ground on the... Oh, yeah, okay. That's probably not the best. It's hooked up to the actual ground on the unit. 205. That's probably a little high. I don't know what 205 is, but... no, I'm not going to be reflowing in the fire anymore. That was a failed move. Yeah, 205 is just too high. Yeah, I think it's 2 mega ohm. I don't know. For a trimmer pot? 204, that I could believe might be good. Okay. I'm probing a trimmer pot between the virtual ground and... let's see if I can find a place to wire it. I don't know, maybe the power for the multimeter. I'm going to put the other probe to monitor it on the other side of the trim pot. So you guys can check it out. That's the schematic. It's not a very good schematic, though. What is the pin? It's not the int pin, it's the other pin that's up there. It's the... Maybe it's buff? Is that how that works? It's probably buff. Maybe? No, it's not buff. It would be... Maybe it is buff. Buff? Question mark to in plus. You don't want to tempt the 9-volt battery. Okay. Now I have that hooked up to the little tweaker screwdriver. I'm getting all ones. Let's see if I turn it all the way to one way. Start getting anything else. Well, that's definitely not the right kind of signal. I would not want to see that. I should be seeing something that kind of goes like 50 hertz. No, not 50 hertz, like 1.5 hertz. Wait. Hold on. I might have to end the live stream shortly. Also, I can't use predictive test. How many people are currently in chat? This may be the wrong thing to... Ooh, that's not good. Just went all the way around. Oh, you know what? I also forgot to hook up the reference ground, so that could mess some things up. Okay, let's try that now. That looks promising. That could also just be the blanking voltage. Oh my gosh, that might be it. As I dial down the voltage, the area of zeros decreases. Okay, let's see if this is it. So 1.9 volts, that's a very small amount of zeros in that field of ones. As I increase the voltage, there's more zeros. 10 volts, 11 volts, 14 volts, and once I hit 20 volts, I think it's going to freak out. No, it's not. It's continuing to behave. So it looks like the data is a little bit noisy. I'm not sure why that is, but it's definitely able to see it now. Huh. Voltage down, voltage up, voltage down. See if I can get... I guess I should zoom in on this for a bit. Okay, so what I've done is I've taken, see the little red lead right there? That's coming off the power for the digital multimeter, the high voltage, the 9 volts. And then see this big dot right, it's hard to get the camera in a view to see it well. The big dot that's right where the brown wire is hooking in. That's the ground, the virtual ground for the multimeter. So that's like about maybe 3 volts less than the 9 volts. And then that's what a lot of the ground on the multimeter is like built on. Then I have this little potentiometer thing, oops, right there. And then that produces a voltage that's a little bit higher than that 0 volts. And then that is, well, that's not good. One of the wires just fell out. Okay, it's still working. And so all of that output, the virtual 0 volt output, is then plugged into in minus on the board. See here, it's plugged into the in minus, it's the orange pin, and then the yellow pin is hooked into that buffer signal on the chip inside the digital multimeter. So that's how that part's working. And like looking at the scope, it looks relatively, it's not clean, but it's definitely, you can definitely make sense of what's going on there. Like as the voltage goes up, you can see it goes down a lot more. So I think we're getting real close to something that might be useful. I'm clipping the video to the screen. What does that mean? What am I looking at, guys? I'm probably also going to have to cut this off shortly. Though I'm very happy with this data. This is, I mean, it's not perfect. So one of the things, I guess we should stop and look at it. Towards the end, it looks like some of the data gets a little bit tripped out. Like there's a random 0 in the data there. There's a random 0 in the data there. Zeros. No zeros. 0. Yeah, there's a couple zeros there. Maybe that's just a matter of finding better caps or maybe designing the front end a little bit better. Almost 10 lines. Let's see if it's almost 10 here. 1, 2. 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10. There's a lot of difference. So maybe, oh, you want the video bigger. Whatever. We're going to be closing the stream shortly. It looks like this is not going to be a stable enough signal, and it looks like we're going to have to do something to clean that up, to make it a little bit clearer as to what's going on. I think I'm going to close this off shortly. Did you guys all have fun? Had anybody actually sat here all the way from the beginning? That's cool. Oh. So how did you guys like it? I know that we still didn't succeed. We're getting there though. I had a lot of fun. These multimeters, man. They are one awesome thing. Ah. How did you guys find the this live stream? Was it just, whoa, you guys are saying a lot. Oh yeah, it was actually a fireplace. There's still a little bit of fire on it. Not much though. It's mostly just embers. Throw some paper in there and a little bit more. Oh, I'm glad. Yeah, I think an open broadcasting system is probably the way to go from here on out. Even though it's kept tripping out the audio in the wrong source, which I don't understand, but let's get a little more fire before we're over. There we go. Oh, so it was like found the stream through subscriptions, notifications. Oh, cool. Yeah. I'm really glad that I was able to actually print the circuit boards and that all that worked out without any issues. I'm rather surprised. I mean, it was a part I've never worked with. It looks like I was able to get the I2S running pretty well. Actually, you know what I'm going to do is I'm going to commit this to Subversion right now, or GitHub, before I forget. Wait, that didn't look right. I guess it is. How did you get... So are you in some sort of special thing that you get alerted on your phone? Do you get alerted every single time that I have a live stream? Yeah, I was really happy about that. The yeah, I get pushed. It's okay. But is it like every time that I do the live stream it happens? Okay, that's neat. Sorry, I didn't mean Subversion. I do use Subversion for my GitHub though, for my uh Oh, well, okay, so if I do anything with the EEV blog, he's going to want to use some like Fluke multimeter or something, and Sprite TM's already done this with a Fluke. So I don't really have that much interest in it. I have a lot more interest in something that's going to be dirt cheap. I don't know who I Love Scotch is. Next stream, it's probably going to be at least a month away. The next month is just a lot of stuff is going on. I also have a backlog of a couple of videos I really want to make. I was working on a bunch of MagFest swagges, as they call them, and there's some really fun stuff with them that I really like to talk about. And I've got a lot of experience with, well, I don't know, I've had a lot of experience with a bunch of Chinese manufacturers, but this was a really fun time, so I'd like to make a video on that. Neat. So mostly just you guys saw the thing live streaming in the list and just joined on in. No, I don't have any plans for the next project. I got a couple things in the works. If they work out, you'll see a video. Also, it'd be neat if I can actually get this to work. Maybe I can get this to work. I'll poke at it a little bit more. Might work out. I think it should be time, though. I really think I should be terminating the stream now. The video from the panel. So the video from the panel came out really poorly, and the audio was just absolutely just awful. So you really can't even understand what's being said. I'm going to have to re-record it. I was really sad about that. The panel that Dylan is asking about is the panel for the MagFest swagges. We actually did a panel at MagFest about the swagges that people had gotten as a function of their like rewards, and we explained a whole lot of stuff at that about how they worked and the story behind them. And we took a video of it, and I was going to post it to YouTube, but the video just did not come out well. I don't know. I guess I'm gonna close it up. Actually, hey Dylan, if you're up for, I can give you all of the materials. I think it would be a lot of fun for you to maybe make the video if you're up for it, or maybe we could just make it together. I don't know. I'm running out of steam for that video, and there's so much that I just can't do with it alone. If there's any chance that you'd be free, say maybe next weekend or something, for us to go actually make the video, that'd be really fun. Dylan. No, I can't teach the KiCad basics. There are other people who do so much of a better job than me. Okay, no, we're getting distracted now. Okay, it's time for me to go close this up. I'm really happy that you guys stuck with this to the end. 78 after a 5-hour stream is an insane amount. I mean, I don't actually know what the peak was, but I think this is a really good one. Overall, people who've watched this in the live streams, do you prefer this kind of thing, or do you prefer the Vive live streams? The Vive live streams, I think, are more fun, but this is, I don't know, they're both a lot of work. Give me a heads up, I mean, just in chat, tell me which one you like more. I guess we'll look for eBay real quick for that other guy. But no, I'd really like to know from you guys, Do you like this better, or do you like the Vive live streams better? Yeah, don't worry. The Vive is going to have the ESPs involved soon. Hey, David Grands, this is the stuff you want. This guy right here, ABC Fab. He goes and hikes the Appalachian Trail, but he'll be back, and he has the absolute best stock for the best prices on eBay. This is like the guy. So if you want to get circuit boards, get them from ABC Fab. He is just awesome. Vive, about the same. I love Scotch. I'm sort of available for work with the ESP. I can't take ownership of projects though. Like I can kind of like consult, but I don't have enough time over the next period to really take ownership of anything. When you see a whole lot of videos, it means I have time. When you don't see a lot of videos, it means I don't have time. Things are really busy. Okay. Okay, the small project, so it's about 50-50. I'll keep that in mind. It's not very often I come across a project that I think would work out like that. Let's unplug everything now. Okay. Got it. I think I'm going to head out, guys. Thanks for coming out. It was a lot of fun. And I hope to see you guys next time. Bye.